Good evening, students. Today in this video we will discuss about the dimension and dimensional analysis. That means the applications of dimensions, right? So we will discuss about dimensions and dimensional analysis, means applications of dimensions. What are dimensions? Dimensions क्या हैं? Dimensions are the raised to the power of fundamental quantities which are used to represent a physical quantity. Means we have to represent a physical quantity into the fundamental quantities. We have 7 fundamental quantities. So first of all, we will represent any physical quantity into the fundamental quantity. Then, while representing, what is the power of those fundamental quantities? That are the dimension. For example, if for area of a square, as you all know that area is equal to side into side. Side is length, so it is L into L. So we can represent area as L into L means L square. Length is a fundamental quantity, so the power of this fundamental quantity, that is the dimension of area. How we will write the dimension of the area? We will write that area has 2 dimensions in length. Area has 2 dimensions in length, right? Let's take one more example of the dimensions. So what are dimensions? Dimensions are the raised to the power of fundamental quantities which is used to represent the given physical quantity. So we will explain one more example to find out the dimension. Density, which is mass per unit volume. Mass per unit volume, right? Mass, it is a fundamental quantity and it can be written as M. And volume, it is derived quantity. Volume is length into breadth into height. So we can write L into B into H. All these length, breadth and height are lengths. So we can write density as mass divided by L cube. So it is M L minus 3. So we'll write density has 1 dimension in mass and minus 3 dimensions in length. So this is how we can write the dimensions of density. Let's solve. the dimension, find out the dimensions for force. Force. As you all know, you have already studied in class 9. Force is mass into acceleration. Mass is fundamental quantity, acceleration is derived quantity. So, mass into acceleration is rate of change of velocity. So, it is change in velocity divided by time. Time is fundamental quantity, but velocity is derived quantity. So, we can write mass we can represent by m into, now the velocity, which is distance upon time, distance upon displacement upon time, right? So displacement I will represent by s divided by time represented by t, and there is one more time for this t, right? Now s is displacement, displacement is also a length. So I can write m into L into T minus 2. So force has one dimension in mass, one dimension in length, and minus 2 dimension in time. So this is how we can find out the dimensions of the physical quantities. There is an appendix in textbook where the dimensions of maximum physical quantities which are used in class 11th and 12th are given. So you should go through those physical quantities and dimensions, right? So you have to go through that appendix. Now, what is dimensional formula? Dimensions are the raised to power to which the fundamental quantities are raised to represent a physical quantity. Dimensional formula is when we have find out the dimensions. Now dimensional formula. So when dimensions are represented in the square bracket, for example for force, the dimensions are m, L, T minus 2, right? So writing these dimensions with their symbols of fundamental quantity in square bracket, this is called as dimensional formula for force. Next is dimensional equation. When we equate the physical quantity, that means if I write force is equal to mLT minus 2 in square bracket, so this is called as dimensional equation. So when a physical quantity is equated with the dimensions of that physical quantity, then that is called as dimensional equation. I hope the dimensions, dimensional formula and dimensional equation is clear to you. Now we have 4 different type of physical quantity on the basis of dimensions. So 4 type of physical quantities. One is, first is dimensional quantities. These are those quantities which have dimensions. For example, force, work, power. So, dimensional quantities which have dimensions. Okay. Second is, these are variable. Dimensional, we can say dimensional variables. The quantities which have dimensions but the value it varies, so they are called as dimensional variable. Then dimensional constants. Dimensional constant. What are dimensional constant? The quantities are having dimensions but are constant. For example, gravitational constant. Gravitational constant. So the value of G, it is constant but it has dimension, and you can find out the dimensions of G by using the formula F into R square by M square. That Newton's law of gravitation, force between any two bodies, it is equal to the product of the two masses and inversely proportional to the distance between them, and is equal to some constant. So this constant is called as gravitational constant. So the dimension of this gravitational constant you can calculate by using this. R is radius, so length, M is mass, M. F we have already calculated, value it is mLT minus 2. We have find out the dimensions, L square upon M square. So the dimensions of G are M minus 1 LQ T minus 2. So this is the dimension for, this is how we can find out for the dimensions. Another dimensional constant, acceleration due to gravity. That is also a dimension, that also has the dimensions same as that of the dimensions of acceleration. Third quantity is dimensionless variables. Third is dimensionless variable. Means it does not have dimensions but the value it varies. For example, theta angle represented by theta, it is the ratio of two sides, two lengths, right? It is L by R. L is also length, R radius, it is also length. So it is dimensionless. But theta can have any value, 30 degree, 60 degree, 40 degree. So it is dimensionless variable, right? Refractive index, you have studied in class 10. It is speed of light in air to the speed of light in medium. So it is the ratio of same type of physical quantity. So it does not have any dimensions, but the value it can vary. Fourth quantity is dimensionless constant. Dimensionless constant. Dimensionless constant means does not have dimension but the value is constant. For example, E, 2, 3, the numbers 4 and so on. They don't have the dimensions and are constants. So that's why this is called as dimensionless constant. So on the basis of dimension, the physical quantities that are of four types: dimensional variable, dimensional constant, dimensionless variable and dimensionless constant. Now let's come to the application part of the dimensions. We can use the dimensions to find out applications of dimensions. So dimensions can be used to convert one system of unit to another system. So first application is conversion from one system to the another system of unit, right? Now while converting, one should keep this in mind that on converting the units, the quantity, physical quantity does not changes. Physical quantity, it is represented by Q and is equal to N into U, where N, it is the numerical value, U is the unit, right? If we change one system, one unit to the another unit, the numerical value changes, but the quantity does not changes. For example, if I have 3 kgs of mangoes, I can say that I have 3000 grams of mango. So on converting one system into the another system, the numerical value changes, but the quantity, it remains same. So we can write Q is equal to N1, U1 is equal to N2, U2. Now here U1, the system, the units in first system of unit, and U2 is in the second system of unit. Here we represent the unit in terms of dimensions, right? So let's understand with the help of example. For example, we want to convert 5 Newton of force into dyne. Dyne is CGS system of CGS units of force. So 5 is the numerical value, Newton, it is the units for force. So we are talking of force. Now the dimension of force, it is MLT minus 2. So we'll write N1 into U, instead of U1 we'll write the dimension. So we'll write M1 L1 T1 raised to power minus 2. So 1 we are writing in the subscript is representing the first system of unit, is equal to N2. Now in the second system of unit, since dyne is also the unit of force, so dimensions will be same. Only difference will be that we will write the subscript 2. So we will write M2 L2 T2 raised to power minus 2. N1 is 5. We have to find out the N. So N2 will be equal to N1 into M1 upon M2 raised to power 1, L1 by L2 raised to power 1, T1 by T2 raised to power minus 2. N1 is 5. In first system of unit, M1, SI system, so mass is measured in kg. M2, mass is measured in gram. Length, L1, in first system, it is measured in meter. CGS system, it is measured in centimeter. Time in both, it is measured in second. So this is 5. Now 1 kg is equal to 1000 gram. So it will be 5 into 10 raised to power 3 multiply by 1 meter is equal to 100 centimeter. So we can write 10 raised to power 2. And 1 second cancel out. So 1 raised to power anything will be 1. So it is 1. So the value is N2 is 5 into 10 raised to power 5. This is the value of N2. So we can write 5 Newton is equal to 5 into 10 raised to power 5 dyne. This is how we can convert one system of unit into the other system of unit, right? So this is the main thing which we have to keep in mind, and the journal formula is for converting one system of unit into the another system of unit. This is the example. So journal formula for this is for finding the numerical value in the second system, it is numerical value in the first system, then m1 by m2 raised to power a. A is the dimension of that particular physical quantity in mass. L1 by L2 raised to power b. B is the dimensions of that particular physical quantity in length. And T1 by T2 raised to power c. C is dimensions of that particular physical quantity in time. So this is the journal formula for converting one system of unit to the another system of unit. This is the first application. Now the second application is checking of accuracy of the result. Checking of accuracy of the result. Whether a given result is correct or not, right? Again we will use the dimensions. For checking the accuracy of the result, we use the principle of homogeneity. That means the dimensions of left hand side should always be equal to dimensions of right hand side. Okay, I will explain it with the help of examples which you have already done. Energy, kinetic energy, it is half mv square. This is the formula you know. Energy, it is ability to do work, force into displacement. So dimension for the energy will be ml2t minus 2. Half, it does not have dimension, so we have to write only the dimension. Half is a constant, dimensionless constant, so need not to write the half. M, the dimension is m raised to power 1. Velocity, which is displacement upon time, so it is lt minus 1 raised to power 2, right? So it is equal to m L2t minus 2. So dimensions of left hand side is equal to right hand side. That means the relation is correct. So very simple. Just you have to write down the dimensions of left hand side and the right hand side. If the dimension of both the sides are same, that means that relation is correct. For example, one more example regarding this. You know that centripetal force, it is equal to mv square by r, right? So force, the dimensions are left hand side, that is force is equal to mlt minus 2. Right hand side, it is m mass, velocity lt minus 1 square on r, it is n, which is m l t minus 2. So dimensions of left hand side is equal to dimensions of right hand side. So this relation is correct. So this is how you can find out the correctness of the relation. Checking of accuracy of the relation. Third application is derivation of the formula, deriving the relation. In In this you will be given the quantities on which a physical quantity depends, and using the dimensions you can find out the relation. For example, let's say the force is proportional to, how it is proportional it is not given, or you can say force depends upon mass, velocity and radius of circular path. Find out the relation between these physical quantities. So what you will write, because force, it depends upon mass, so you will write force, it is proportional to mass, anything raised to power, let's say A, velocity raised to power B, and radius raised to power C. Now you will write down the dimensions of force, mLT minus 2. You will write down the dimension on both sides. Dimensions of mass, m raised to power A, velocity, which is del t minus 1 raised to power B, r, radius, length raised to power C, is proportional to MA LB plus C P minus P. Powers, bases are same, powers are added. Now equate powers of mass, length and time on both sides. So we can write A is equal to 1, B plus C is equal to 1, minus 2 is equal to minus B. So when minus 2 is equal to minus B, that means B is equal to 2. Putting the value of B in this relation, 2 plus C is equal to 1, so C will be equal to minus 1. Now put the value of A, B, C in this relation, so you will get force is equal to some constant, mass raised to power A is 1, so M1, velocity raised to power B, so V square, and radius raised to power C minus 1. So it is F is equal to mv square by r. This is the relation. So very simple. Just what we have to do, we have to write down the dimensions of all the physical quantities on which a given physical quantity depends. Bases are same, powers are added. Equate the dimensions of mass, length and time on both sides, and you will get the relation. So very simple. Try few examples at home so that you will be able to solve the questions. Now the last is, yes, the last one. Now the limitation of dimension is you can't find out the constants. In case of derivation of the formula, the value of k you can't find out with the help of dimension. That is always calculated experimentally, right? Now the fourth application, finding the dimensions of unknown quantity. Finding the dimensions of unknown quantity. Right? For example, force is equal to Vt plus At square. Right? So this A is, let's say, A is unknown quantity. We have to find out the dimension. Forces, let's say, Bt. It is force is equal to Bt plus A and B both are unknown quantity. We have to find out the dimensions of A and B. Now, how to find? According to the principle of homogeneity, the dimensions of both sides should be same. That means if on the left side this is force, so the right side should also be force. Now we know that only same type of physical quantities can be added or subtracted. So that means the dimensions of this BT as well as AT square should be that of the same as the dimensions of force. So dimension of force, it is mLT minus 2, right? So because left hand side should always, dimensions of left hand side should be equal to right hand side, so BT plus AT square should also have the dimensions of force. So we can write BT should be equal to mLT minus 2. T is time, so B will be equal to mLT minus 2 divided by T. So it is equal to mLT minus 3. This is the dimension for B. Similarly, because same type of physical quantities can be added, force can always be added in force. So that means AT square should also be equal to force, right? So we can have A into T square should be also equal to mLT minus 2. So this A will be equal to mLT minus 2 divided by T square. So it is mLT minus 4. So dimensions of A will be mLT minus 4, right? So this is very simple. This is how we can find out the dimensions of unknown physical quantity. Simply, you have to keep one thing in mind, that the principle of homogeneity, that means the dimensions of left hand side should always be equal to right hand side, dimensions of right hand side, and only same type of physical quantities can be added or subtracted. I hope this video will help you to understand about the dimensions. Thank you.